Hello everyone, myself Dhanavi, studying in Sri Venkateswara College of Engineering from the Department of Computer Science. Today I am here to explain about angle, projection, reflection, rotation, contraction and expansion. Introduction. Angles and projection are the concepts in geometry and in mathematics. Reflection, rotation, contraction and expansion are the transformation of geometric figures. Introduction to angles. Angles are a fundamental concept in mathematics. They are formed by two rays that share a common endpoint called as the vertex. Angles can be measured in degrees or in the form of radians. Types of angles. Right angles. Right angles which measures exactly 90 degree. Acute angles that measures less than 90 degree. Obtuse angles which measures more than 90 degree but less than 180 degrees. Summary on angles. Understanding angles is crucial in various mathematical concepts and applications. They provide a way to measure and describe the relationship between lines and the shapes. Mastering angle enhances problem solving skills and lays foundation for the advanced mathematics. Introduction to projection. Projection is a fundamental concept in mathematics. It involves the process of mapping or transforming objects onto a lower dimensional space. Projections are widely used in various branches of mathematics, including linear algebra, geometry, and calculus. Projections in geometry. In geometry, projections refers to the representation of three-dimensional objects onto a two-dimensional plane. Different types of projections such as orthographic and perspective are used depending on the purpose and context. Projections are employed in architecture, engineering, and technical drawing to visualize the object in a simplified way. Examples on projections, which includes orthographical projection used in engineering drawings, perspective projections used in realistic 3D renderings, oblique projections used in the architectural drawings. Understanding projections. A projection is a linear transformation that maps a vector onto a subspace. It involves finding the closest point in the subspace to give the vector. Projection can be orthogonal, meaning the subspace is perpendicular to the vector being projected. Applications of projections. Projections are used in computer graphics for rendering 3D objects onto a 2D screen. They are used in machine learning for dimensionalistic reduction techniques like principal concept analysis, that is PCA. Projections are also used in physics to study the motion of objects in different dimensions. Summary on projections. Projections are a fundamental concept in mathematics involving the mapping of objects onto lower dimensional spaces. Orthogonal projections are the most common type, preserving vectors, length, and involving perpendicular subspaces. Projections have wide applications in computer graphics, machine learning, and physics, among the other fields. Introduction to reflection. Reflection is a transformation in which a line figure is filled over a line called the reflection. Reflection preserves the size and shape of the figure but changes its orientation. The line of reflection is the perpendicular which bisects of each segment, joining a point and its images. Properties of reflection. Reflection is an isometric, meaning it preserves distance and angles. The image and the pre-image are congruent, meaning they have same size and the shape. Reflection is an example of rigid transformation, which means it preserves the size and shape of the figure. Notations for reflection. The notations for a reflection is usually written as R of L, where R represents the reflection and L represents the lines of the reflection. Another common notation in R is Rm, where M represents the slope of the line of reflection. Reflection can be denoted by coordinates such as x, y for reflection across the y-axis. Applications of reflections. Reflections are used in geometry to visualize, solve various problems. They play a crucial role in symmetrical figures and the patterns. Reflection can be used to prove theorems and solve equations involving geometrical figures. Real world applications of reflection. Reflections are used in architecture and designing to create symmetrical building and structures. They are used in art to create visual balance and symmetry. Reflections are also used in mirrors, lens, and other optical devices to redirect light. Examples on reflection. Example 1. Reflecting a triangle across the x-axis would result in a triangle with the same vertex but flipped upside down. Example 2. Reflecting a rectangular across the y-axis would result in a rectangle which the same length and width but flipped horizontally. Example 3. Reflecting a point across the line y is equals to x would result in a point with its x coordinates and y coordinates swapped. Summary on reflection. Reflection is a transformation that flips a figure over a line known as the line of reflection. It preserves size and shape but changes orientation. Reflections are isometric and rigid transformation and they can be denoted by using various notations. Types of reflections are horizontal reflections and vertical reflections. Introduction to rotation. Rotation is a transformation that turns an object around a fixed point. The fixed point is called as the center of rotation. Each point of the object moves in a circular path around the center. Introduction to rotation. Rotation is a transformation that turns a figure around a fixed point called the center of rotation. It preserves the shape and size of the figure but changes its orientation. Rotation can be clockwise or counterclockwise and the angle of rotation is measured in degrees. Degrees and radians. Rotation can be measured in degrees or in radians. In degrees, a full rotation is 360 degree. In radians, a full rotation is 2 pi, approximately 6.28. Properties of rotations. Rotations are commutative, meaning the order of rotation does not matter. The composition of two rotations is also known as a rotation. The angle of rotation is preserved under a composition. Applications of rotations. Rotations are used in computer graphics to animate objects. They are used in robotics to control the movement of robotic alarms. In physics, rotations are used to describe the motion of objects in space. Real life examples. Clock hands rotating around the clock face, Earth's rotation causing day and night, a gymnastic performing a priority. Summary on rotation. Rotation is a fundamental concept in mathematics. It involves turning a figure around a fixed point. Rotation have various applications in different fields. Introduction to contraction. Contraction is a transformation that reduces the size of a figure uniformly in all directions. It proportionally reduces the length, angle, and area of the original figure. Contraction is commonly used in map making to fit large areas onto a smaller surface. Properties of contraction mapping. A contraction mapping has a unique fixed point, which is a point that remains unchanged under the mapping. The fixed point theorem states that if a contraction mapping exists on a complete matrix space, then it has unique fixed point. Contraction mapping has Lipschitz continuous with the Lipschitz constant less than 1. Contraction example. Examples of contraction include shrinking of a balloon when air is released, compression of a spring when the pressure is released, decrease in size of a rubber band when stretched. Summary on contraction. Contraction is a powerful mathematical concept that has application in various branches of mathematics. It helps simplify expressions, solve problems efficiently, and establish important theorems. By understanding and utilizing contraction, mathematicians can explore new areas of research and develop innovative mathematical techniques. Introduction to expansion. Expansion is mathematical refers Expansion in mathematics refers to the process of representing a mathematical expression in an expanded form. Expansion allows us to simplify and manipulate complex algebraic expressions. It involves distributing and combining like terms to relieve and underlying structures of the expression. Basic of expansion. Expansion is commonly used in algebra to expand binomial theorems, trinomial theorems, and polynomial theorems. The distributive property is a fundamental concept used in expansion where each term within a parenthesis is multiplied by the terms outside the parenthesis. Expansion allows us to multiply out and simplify expansion by removing parentheses. Applications of expansion. Expansion is useful in simplifying algebraic expressions, solving equations, and factoring polynomials. It allows us to identify patterns, simplify calculations, and solve complex problems. Expansion is a fundamental technique used in various branches of mathematics, including calculus and linear algebra. Expansion examples, which includes inflation of balloon with air, expansion of metal rod when heated, growth of plant over. Summary on expansion. Expansion is powerful technique in mathematics that simplifies and manipulates complex expression. It allows us to reveal the underlying structure of an expression and solve various mathematical problems. By mastering expansion, we can enhance our mathematical skills and problem solving abilities. Conclusion. Angles and projections, reflection, rotation, contraction, and expansion are the fundamental concepts in geometry and mathematics. While understanding these concepts helps in visualizing and manipulating geometrical figures, the applications of these concepts span various fields from engineering to the art and science. Thank you, everyone.